Hi everyone, in today's lesson from Unit 3, we'll be writing triangle congruence proofs. So a proof is a formal way to prove that something is true in geometry. Our focus today is just on proving triangles congruent. So you may want to put a reminder at the top of your page of the list of the 5 methods that we've used for proving triangles congruent. And those are side, 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 angle, side, angle, side, angle, 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 side, also known as side, angle, angle, and hypotenuse leg, used only for right triangles. Remember, a couple of things that do not work would be side, side, angle, and angle, angle, angle. So just remember, we should not be giving these two as reasons for our triangles to be congruent. Alright, as always, we want to start with our given information, and I really want to emphasize that you should be marking things in your picture. That's the given information, and then put it into your proof. So don't forget to mark, but don't forget to also put it into your 2-column proof. So first we have line segment BC and line segment CD, and this statement is saying that they're congruent to each other. So mark them congruent and put that as line 1 in your proof. So line segment BC is congruent to line segment CD. The reason, how we know that, it was given to us. So we're just simply going to write given. Alright, now that's just a fact. That's just a pair of segments that are congruent. We're not going to do anything else with it. There's no follow-up to that. So I'm going to go right ahead and add our second piece of given information, which says that line segment AC right here bisects angle BCD. So AC is coming in and dividing angle BCD into 2 congruent angles. Right, this angle right here is angle BCD. Okay, so first add to line 1 that statement AC bisects angle BCD. You could write it as a separate statement, but you can also put your given information together. Right, the takeaway from that was that it created 2 congruent angles, and those angles are angle BCA congruent to angle DCA, and that's by definition of an angle bisector. Okay, so far in our proof, we have a pair of sides that are congruent, and now in step 2, we have a pair of angles congruent. I'm just going to make that list below the picture as well. Alright, finally, we're out of given information, so this is where you want to go to your picture and see what else you can say is true for sure. And what I know is that these 2 triangles share side AC in common. So by the reflexive property, in line 3, we can say that segment AC is congruent to itself. And again, that was by the reflexive property. Alright, that's another pair of sides congruent. And I know we have the order right here, side, angle, side, but verify it in your picture. Side, angle, side, congruent to side, angle, side. So yeah, we have side, angle, side. So we're ready to make the statement that our 2 triangles are congruent. Triangle ABC congruent to triangle ADC by side, angle, side. Okay, on to our next proof. Right, our first piece of given information, I'm going to go right ahead and put it into my proof, and then I'm going to mark it in my diagram. It says that line segment AB is congruent to line segment BC. So I'm going to mark AB, which is on this side, congruent to BC on this side. So I'm using the highlighter tool, but I'm also going to use that little tick mark to say they're congruent. This time I'm going to split up the given information, because one thing you'll notice on the practice, if you do it online, is the given information will be separate. Like you'll have one piece of given information per line. Okay, so our second piece of information says the line segment BD bisects, that's a key word, bisect. It bisects line segment AC. Okay, so what we have here is line segment BD coming down, and it's going to be bisecting AC. So here's AC. So when something is bisected, it's divided into two congruent parts. Okay, so first, let me put in here that this line is given information. This is right here in our given information. And then what we take away from that, by using that keyword bisect, is that we end up with line segment AD congruent to line segment DC. And that's by definition of a segment bisector. Okay, so let me just go back and add a few notes. We have one pair of sides congruent in line 1, so we have an S. This is side congruent to side. We just got another pair of sides congruent, so that's another S. And now we're out of given information. We don't have things like vertical angles in this picture, so we really can't mark any angles congruent. But notice that our two triangles share that middle line segment. So what we're going to do next is say that line segment BD is congruent to itself by the reflexive property. And you're going to notice that this happens quite often when triangles are back to back. We're going to use that reflexive property a lot. All right, that's a third pair of sides congruent to each other. So we're going to say side, side, side. So name your two triangles and look right up here for that proof statement. They said triangle BAD, so they started at the top and went outside to A. So that's going to be congruent to triangle BCD. Remember that the order is important. Again, our method for proving the triangle is congruent, side, side, side. And that's it for that one. Okay, in number 3, we have some slightly different given information. So in this case, I am going to split up the given information. On line 1, we're going to put that GH is parallel to JK. So I'm going to add some arrows in here. And extending those line segments might help you, because sometimes it helps when parallel lines are drawn a little bit longer. So on line 1, we'll put in line segment GH is parallel to line segment JK, and that's given. All right, I'm going to jump right in and take something away from this. In other words, I want to figure out why they're giving this as a clue. So I'm going to mark in here with a highlighter line segment HJ. Now notice that HJ is a transversal. So hopefully you remember that when two parallel lines are cut by a transversal, we end up with alternate interior angles that are congruent. So that would give us angle H congruent to angle J in line 2. And we can get away with one letter for naming those angles because there's no confusion as to which angle we're referring to. And our reason would be the alternate interior angle theorem. Okay, we're going to use that same given information to get another pair of angles congruent. So if you look at line segment GK as a different transversal, notice that angle G and angle K are also alternate interior angles that would be congruent. So right there in line 2, don't go on to line 3, but keep it in line 2, you can say angle G is congruent to angle K. Now, it's the same reason, so that's why I can put it there in line 2. Right, we're done with that piece of given information, so we want to go on to our next and final piece of given information. And it says that point L is the midpoint of line segment HJ. Alright, so if L is the midpoint of HJ, so again, HJ is my yellow line in my picture. If L is that midpoint, then what it does is it divides the segment into two congruent parts. So our takeaway, and what we're going to put in line 4, is to say that line segment HL is congruent to line segment JL, or LJ. The key word in line 3 was midpoint, so we're going to use that as our reason for line 4, definition of midpoint. Alright, we have enough information to say that these two triangles are congruent because we just proved a pair of sides congruent. So notice we've got angle, angle, side, congruent to angle, angle, side. So that's going to be our reason, angle, angle, side. And naming the triangles. Use the markings to help you. If I name the first triangle, the triangle on the left, triangle GLH, then I have to name the second triangle, triangle KLJ. And notice that I'm copying it from that proof statement too. And they're congruent by angle, angle, side. I also want you to note that you can also do this one by proving vertical angles congruent. So we can also prove vertical angles are congruent. And then your reason would be, you would use angle, side, angle. Okay, so there's very often more than one way to do a proof. Alright, our last proof has just one piece of given information, but it's still enough to prove that our triangles are congruent. So it says that line segment QS and line segment RT bisect each other at point U. Alright, so that's given. Alright, and line 2, we're going to say what we can take away from that. So what we have here, we have line segment QS, line segment RT. You can see that they intersect at U, and they're bisecting each other. So they each go through the midpoint of the other one. So QU will be congruent to SU. And TU will be congruent to RU. Right, and that's by definition of a segment bisector. Well, that gives us two pairs of sides that are congruent. So we have two S's already. We want to put that out here. Alright, now we're done with segments, and we can't prove that QT is congruent to RS. We don't have any reason to support it, so we have to look at the picture and see what else we can prove. And right away I can jump in and say those two angles are congruent, because I can see that they're vertical angles. We do have to name them with 3 letters though, so say angle QUT is congruent to angle SUR. And again, that's a pair of angles. And you can either say vertical angles theorem or just vertical angles are congruent. Alright, finally, you're ready to make your conclusion. These two triangles are congruent, so switch the angle symbol to a congruent sign and say triangle QUT is congruent to triangle SUR. And it's by side, angle side, because the angle is in between the two pairs of congruent sides. Alright, that's it for the notes, so give practice number 5 a try.